So 1.6 polynomial functions and in behavior. So again, on in behavior, I want you to think of that little dance that you get to see that guy do all the time. All right, and so really, we're just going to put some notation on that little dance. All right, Asher's going to be our first reader. We got some fill in the blanks. Here we go.
In behavior. The end behavior of a function describes how a function
behaves
as it moves infinitely to the right and left.
Keep going.
In other words, the end behavior is what happens to the values of
f of x
as x increases or decreases without bound.
All right, so now I'm going to talk about this increasing and decreasing without bound. Which way does x move on a graph? Left and right, right? And when it moves left, the value of x is what? Decreasing. Okay, negative, decreasing. All right, that's beautiful. All right, and then as it moves right, it's what? Increasing. Are we cool with that? All right, and so then which way does f of x, or aka y, move? Up and down, right? And so if it goes up, it's said to increase without bound, and then when it goes down, it's said to decrease without bound. All right, and so let's look at this new notation that you haven't seen before, but let's just play along with it. So this is how you read it. So it's a limit as x approaches negative infinity. All right, so if x approaches negative infinity, it moves left. If it goes negative infinity, it moves left. X is moving left. Does everybody follow me on this? It's decreasing without bound. As x decreases without bounds means that. And then of f of x. So then you're actually trying to figure out what the y is doing. So my right-hand behavior, all right, as x approaches infinity, it means it's moving which way? To the right. All right, it increases without bound. All right, so let's look at our examples here. All right, and so on this first one, I need to find my left hand and my right hand behavior. So I want to find a limit as x approaches negative infinity of this function. So if I'm moving left, x is going to negative infinity, and then I need to describe what's happening to my y values. So as this function moves left, what is happening to my function? It is going which way? Up. As it moves left, it is going up. And the way we describe that is it equals infinity. It is increasing without bound. So the way that we'd read this, I'm not going to write it verbally. I'm really not. So this is the limit as x decreases without bound. My function increases without bound. My limit is x versus negative infinity. It goes to infinity. All right, I'll read it again. The limit is x decreases without bound. My function increases without bound. All right, let's do it again. So now I'm going to talk about the right-hand behavior. So right is I'm taking a limit as x approaches infinity. Okay, and so now I'm moving that way. And so as I go to the right, as I go to x approaches infinity, which way is this graph moving? Down. And so now I describe that with negative infinity. All right? And so the way that it could be worded is my limit as x increases without bound, my function does what? Decreases without bound. All right, cool. Let's do it again. So let's look at part B now. So now if I do my left-hand behavior, I'm taking a limit as x approaches negative infinity because I'm moving left. So as this thing moves left, what's happening to my function?
Decreasing and increasing, so going up.
It's going up. And so it's going up. So how do we say it's going up? It goes to positive infinity. All right. And now let's do it for the right-hand behavior. So now we do a limit as x approaches infinity. So as it moves to the right, which way is it moving? As it moves to the right, which way is it moving? It's moving up. And so we call that positive infinity. All right. So the way we could read that last one is the limit as x increases without bound. My function also increases without bound. All right. All right, cool. So let's sketch it. So this first one, my limit is x approaches negative infinity. My function goes to negative infinity. So what does this mean? So what does this limit as negative x approaches negative infinity mean? As it moves what? Left, it is going down. So as it moves left, it is going down. And then this other part, as it moves what? Right, it is moving down. Now, do we know anything about the middle part? No. All right. Robbie's little jig is going to do like something like that because he's pretty cool. All right. We don't know. We don't know what it does in the middle. However, the end behavior, that's what it's doing. All right. All right. This next part. So my limit as x approaches negative infinity. So what does that part mean again? As it goes left, my function is moving down. And then my other part, limit as x approaches infinity. What's that mean? As it goes right, it is going up. Now, do I have any idea what happens in the middle? Not at all. So you just got to connect them somehow. All right. Make sense? Cool. We are moving. All right. So we're going to do some fill in the blanks. I'll talk about them. However, let's just do it. All right. Let's talk. All right. I need a beautiful reader up in here. And Penelope's going to be our reader. Oh, my goodness. Let's do it.
For polynomial equations, it is easiest to find the end behavior of the
Right side first.
the right side. Goes
To infinity.
if the leading coefficient is
Positive.
goes
To negative infinity.
if the leading coefficient is
What do you think?
negative.
Negative. Very nice. All right. So let's talk about it. So if I have, let's say I have 3x to the fourth. All right. If I have 3x to the fourth, what does that look like? What does it look like? Show me with your hands. End up with something like that, right? And so if I have a positive coefficient, guess what my right-hand behavior does? It goes up. All right. Now, if we think about even a 3x to the fifth, what's a 3x to the fifth do? Good. All right. And so it's a positive coefficient. My right-hand behavior does what? It goes up. And if I have a negative coefficient, so if I have negative 3x to the fourth, it's like this. And then if I have a negative 3x to the fifth, that goes like this, right? And so then it would be going down. All right, cool. Let's keep going, Penelope.
The left side goes in the
Same.
direction as right if the degree is
What do you think? Even.
goes in the
Opposite. Very good.
direction as right if the degree is
Odd. All right. So let's talk about an even and an odd. All right. So if we talk about the same direction if it's an even, so do you see how it starts up and ends up, or starts down and ends down? And then if it's odd, it starts down, ends up, or starts up, ends down. All right. So now we're just putting infinities and negative infinities to them. All right. So positive infinity means going up, and negative infinity means going down in these cases. All right. So I got a 4x to the fifth. All right. Where does it start? Where does my left-hand behavior? It starts down. So how do we describe that? With a negative infinity. And then it's going to end what? Up. And so my right-hand behavior is infinity. All right, let's do another one. So in part B, I have 1/2 x to the fourth. So where does that start? It's a positive even. So where does it start? Starts positive infinity, and where does it end up? Positive infinity. All right, that's one of those guys. All right, so I want you to do C, D, E, and F. This line's going to help me out with part C. So what do we know? We have a negative what? A negative even. Negative even, right? And so where's that start? Negative infinity. Where's it going to go? Negative infinity. All right. On part D, pick somebody. Cohen. What do we got going on here?
Negative infinity.
No. I have a negative odd power. So a negative odd power starts where? positive infinity, and then it goes to negative infinity. All right, so some people call it an in-behavior model. So like for part E, do I care about this 8x squared or the 4? No, all I care about is this negative x to the 5th. Okay, some people call it an EBM or in-behavior model. And so this is a negative odd. And so what does the negative odd do again? It starts where? At positive infinity, and it goes to negative infinity.
Only care about that because it's the highest degree.
It's the highest degree. That's right. All right. So on F, I have 2x and x and negative x. So what would be my in-behavior model on that one? Negative 2x to the third. So I have a negative 2x to the third. And so what's my left-hand limit there? It starts out at infinity, and then it's going to go to negative infinity. Because, again, it's a negative odd power. All right. So on example 4, sometimes we need to just like figure out what my in-behavior model is doing, and then we're going to put limit statements on it. So I have negative 3x to the 4th. I have negative 3x to the 4th. So where does this start? I have a negative even power. So where does it start? Down. Then where's it going to go? Down. It's an even. Okay? And so now we're just going to put a limit statement on it. So we're going to say a limit as x approaches negative infinity of f of x. So what does this mean? As x approaches negative infinity, so it decreases without bound, what does my function do? It decreases without bounds, and we're going to call that negative infinity. So now we're just putting a limit statement on it. Okay, that's the new part to you right now. And so now we're going to talk about its right-hand behavior. So now we're going to say a limit as x approaches what? Positive infinity. So it's basically saying it increases without bound. It is moving to the right. And so as it moves right, what is my function doing? It is going down. It decreases without bound. All right. All right, so let's look at part B now. So what's my in-behavior model? The only thing I care about on this one. 5x cubed. That's it. All right. And so I have a positive odd power. So what does the positive odd power do? Starts down and ends up. All right. And so now we're going to put a limit statement on it. So now we're going to do a limit as x approaches negative infinity of g of x, because this is an f now, it's g. And so as it goes left, where does it go? It goes down, and we call that negative infinity. All right, let's do the right side now. So now I have a limit as x approaches what? Positive infinity. And so as it moves right or increases without bound, my function does what? It increases without bound, so we call it positive infinity. All right? All right. All right, so we're going to graph this thing in our handy-dandy calculator. And so hopefully we can get a picture that looks something like this. So I need to do a limit as x approaches negative infinity. So as I move left, what is my function doing? It's increasing. So we're going to call that what? Positive infinity. And then I'm going to do a right-hand behavior. And so now I do a limit as x approaches infinity. And so as I move right, what is it doing? It's also increasing without bound, and so we're going to call that positive infinity. All right, let's graph B now. All right, so when we graph part B, we should be graphing that. And now we got that one. All right. Does it go to positive infinity or negative infinity on these now? It doesn't. It doesn't. So as x approaches negative infinity, what does it look like it's doing? Does it go down or does it go up? No, it kind of gets flat. Does anybody see where it kind of gets flat at? 2. And then when I go to positive infinity, as I move to the right, my value also goes to what? 2. This is actually the definition of a horizontal asymptote. I'm forecasting what's happening later on. You guys remember doing horizontal asymptotes? You look at the higher powers. So if you have an x on top and an x on the bottom, do you see how they're the samesies? So now you look at the coefficients. So now you have 2 over 1, which is also known as 2. All right? And so that's really what's happening. All right? And so let's look at C now. Let's graph C. All right, so hopefully we get a picture that kind of looks like that. And so when I take a limit as x approaches negative infinity, so as it moves left, what y value does it look like it's going to? 0. And then as it moves right, as x approaches infinity, my function is also going to what? 0. And this is because my denominator wins. Do you see how x squared is in my denominator? That's higher than an x to the power of 0, and if the bottom wins, you get 0. All right? And so that's basically forecasting a horizontal asymptote for later on. All right?